Alright, today's lesson really just building on what we did previously with operations with radical expressions. Very similar. We're going to see some binomial expressions. Remember, binomial just means we're looking at two terms there. And so here's the big things we're going to be looking at today. We're going to add and subtract radical expressions. We'll also multiply and divide radical expressions. Now the key here, okay, as we add or subtract, their radical parts must match exactly. So the stuff under the radical has to match, and they've got to be the same root, of course. Okay, so they have to match exactly. So let's just look at a couple examples. I think that's the easiest way to see it. 7 cube roots of 5 minus 2 cube roots of 5. Well, notice those match. Okay, so well, what's 7 minus 2? 5. And then we've got cube roots of 5. So in a way you can think of them as like terms. This part, it's not a variable of course, but it has to match, and then you just add or subtract. Pretty straightforward. How about this guy? 10 fifth root of 14, 9 fifth root of 4. Well, notice those don't match. In 14 I can't simplify. 2 times 7, there's nothing I can simplify. And so this is already as simple as it'll get. There's nothing you can do to it. How about this guy? Square root of 72, square root of 32, square root of 18. Well, gosh, none of those match. So you may say, well, I'm done. Well, maybe you can simplify it first. Okay? So see if you can simplify and then go from there. So square root of square root of 72. Well, that's the same as square root of 36 times 2. Now, I chose 36 because that's a nice perfect square. Square root of 32 is, what are we looking at? 4 times 8, we could do 16 times 2, right? So how about 16 times 2? And 18, of course, is 9 times 2. Now, let's simplify each of those. So square root of 36, I can pull out. Remember going back lessons, how you could separate those if that helps. So this would be 6 root 2. So square root of 72 is the same as 6 root 2. This would be 4 root 2. Square root of 16 is 4. And of course this would be 3 root 2. Now notice, at first they didn't match, now they all match. So now we can just add them. 6 plus 4 is 10, plus 3, so 13 root 2. Is that simplified? How about this guy? Very similar. Oh, I got some subtraction there, no worries. Cube root of 27, 3 times 3 times 3. So this is the same as just negative 3. Minus 6 cube roots of 3. Can't simplify that, of course. And then here's the same thing as we just saw here. So the cube root of 27 is just 3, so 5 times 3 is 15. Negative 3 plus 15, well, that's 12. And then we'd have our cube root of 3 there. So there's our expression. Just simplify the best you can. Okay, let's do a little multiplication. Now, here's a common mistake I see when we see things squared. We'll just square this guy and square this guy. Remember, this means, okay, and I would encourage you, take a sec and write it out to remind yourself so you don't make this silly mistake. And now you multiply this whole thing out, right? So I'm going to multiply root 7 by root 7, so I'll do right here, and then right here. So root 7 times root 7 is 7. Root 7 times root 5 is root 35. Again, both under the radical still. Now I'm going to take my root 5 through. So root 5 times root 7 is root 35. Root 5 times root 5 is 5. Of course, now I can simplify. 7 plus 5 is 12. And I have 2 root 35s. And the square root of 35 is not going to simplify for us. So that would be my final answer. Now this is really the same thing, right? Once you write this out. So again, I just want to show that. So let's multiply this guy through there and here, and then this guy through there, and then really all we're doing is distributive property. So 3 times 2 is 6. 3 times 4 root 5 is 12 root 5, right? 3 times 4, and then you still have the root 5. 2 root 5 times 2, that would be 4 root 5. And then times 4 root 5. So 2 times 4 is 8. Root 5 times root 5 is 5, so we have 8 times 5, so that's actually 40. That's just a nice number. And then you simplify. 6 plus 40 is 46. And 12 root 5 plus 4 root 5, we've got 16 square root of 5. Okay? How about this guy now? Same thing, it's just going to be kind of a special case I want to illustrate. So we're going to multiply these through. Let me show you what happens. 5 times 5 is 25. 5 times negative root 3 is minus 5 root 3. Root 3 times 5 is 5 root 3. Root 3 times negative root 3 is minus 3. Now notice 25 minus 3 is 22. Negative 5 root 3 plus 5 root 3 goes away. Hey, so our answer is just a nice number. This, you may remember this word from previous lesson, is a conjugate of this term. Notice it just has a different middle term. So that's a nice way. If you want to get rid of radicals in an expression, multiply by its conjugate, and hey, you get nice, excuse me, nice rational number. We're going to build on that. We did a little bit of that previous lesson. We're going to build on that here. So to rationalize the denominator of a binomial, multiply by a form of 1 that includes the conjugate. Okay, so I want to basically get rid of this square root of 11 down here. I don't want any radicals in the denominator. And so I'm going to multiply by this, 4 plus square root of 11 over 4 plus square root of 11. Now I'm multiplying this expression by 1, and so that's perfectly legal in algebra, right? Let me just throw parentheses here, maybe to keep track of things. And now you do what we just did on the previous examples. You're just multiplying stuff out, and then we're going to simplify. Now again, here's the key. Where did I get this number from? It's the conjugate of this number right here. I just changed the middle sign. So let's multiply this top one out. 3 times 4 is 12. 3 times root 11 is 3 root 11. Take the other ones, 4 root 11 plus 11. Right? Of course, we simplify that. The bottom, once you understand the pattern, 4 times 4 is 16. Middle term's going to cancel. Don't worry about it. Negative 11 times 11. They're both under square root, of course. So that's just going to be minus 11. So let's clean this up. So I have 23 plus 7, square root of 11 looks like, all over 5. And that's not going to simplify. Now, if these would simplify a little, I'd take care of it, but that looks like what we're going to get for this one. Okay, how about this one? Very similar. I'd encourage you maybe even pause the video and give this a try. So there's the conjugate, right? Hopefully that's kind of making sense to you. Recognize patterns. Math's all about patterns. Let's multiply this one out. So 30, I'm going to kind of shorthand this one a little bit. So 30 plus 5 root 2 plus 6 root 2. So that's plus 11 root 2. Root 2 times root 2, of course, is just 2. And on the bottom, we get 25 minus 2. Hopefully you can kind of see where those are coming from. So 32 plus 11 root 2 over 23. There would be our final answer, okay? So really not bad. You're just multiplying, adding, subtracting. Just happen to have radicals in the expression. So hope you have a great lesson. And as always, if you have questions, please reach out.